Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon to Madam Nur Hidayah and my fellow friends. Our group will show you how to solve Vision Mathematical Inductions for past year June 2014. But before we start, I would like to introduce first my group members, starting with myself. My name is Nur Aisyah Shahinda binti Asri. Next.
Assalamualaikum, my name is Judge Sofia binti Nazruddin.
Assalamualaikum, my name is Nur Fatifah Rana binti Zaid.
Assalamualaikum. My name is Nur Izzati binti Muhammad Razak.
Okay, and the last one is Nur Nadira binti Muhammad Hamid.
I will present to you in the introduction part. Next. So, what is induction? Induction is the best way method for proving that each of the statements in the infinite list is true. It will be used when the quantifier for all appears in the statement B. Next, for every integer n equal more than a, something happens. Next. So, in the induction, we will use integer number. What is integer? An integer is a number that can be written without a fractional component. For example, 4, 0, negative 1000. So at the right side, we can see the non-integer numbers, such as the decimals, fractions, and mixed units. Next. So here is example of induction, which has n equal to n multiply with n plus 1 divided by 2 for all n equal more than 1. So we can just calculate it like n equal to 1 is 1, step by step. Like n equal to 2, we get 3, n equal 3, we get 6. But until when? How about after the n? So here we use induction method to make it easier. So here is the steps to do induction method. First step, we need to verify that P1 is true. Second step, we need to use Pn as the induction hypothesis and assume that Pn is true. And the last step is to prove that Pn plus 1 is true. So why we need the induction? Because it is used in a computer science field to prove general structures such as tree-stem as structural induction. So I will pass to my friends to present about the question past June 2014.
Okay, for question A, prove by mathematical induction that for every integer n more than or equal to 1, 1 plus 4 plus 7 plus plus 3 n minus 2 equal to n 3 n minus 2 over 2. So, as stated in the introduction, the first thing we must do is to verify P1 is true. In this situation, we must determine the equation right hand side and left hand side. We determine that 1 is our left hand side and 3 n minus 2 over 2 is our right hand side using this equation. We must solve the equation from right hand side by substituting n equal to 1 in order to get 1, 3, 1 minus 2 over 2 equal to 1. Since left hand side and right hand side are equal, P1 is true. Next is to assume Pn is true. Take note that our Pn is derived from our question, so we can just make an assumption and skip performing any calculation. So next, we then move on to the following phase, which is proof that Pn plus 1 is true. We must always add 1 to our current Pn whenever n is. In our example, it is turned into n plus 1, 3n plus 1 minus 1 over 2. We may reduce the equation to obtain 3n squared plus 5n plus 2 over 2. Our main conclusion is to prove right hand side of Pn plus 1 by using Pn. It should be noted that 3n plus 1 minus 2 actually come from 3n plus 3 minus 2. We simplify the equation after the left hand side by 3n plus 1, which come from 3n plus 3 minus 2, and we get the same result as our third set. Hence, n plus 1 is true, therefore Pn is also true. Next, I will let Nadira to continue our presentation.
Okay. Okay, I will continue for thinking process for question A. For thinking process, I will explain to you how the solution is conducted for question A. Okay, in this question, it is stated that for every integer n more than or equal to 1 is integer. That means n is element in Z. The notation Z is referred to integer number, and the n value must be larger or equal to 1. So, in the first step of verifying P1 is true, we should try to prove that the equation result of right hand side is equal to left hand side. So like in this question, the first term that you can find in the left hand side result is 1, this one. As for the right hand side, we will need to substitute n equal to 1 into a n bracket 3n minus 1 over 2. Then you shall see that the equation result of right hand side is actually equal to left hand side. 1 equal to 1. So we must write a conclusion that left hand side is equal to right hand side. P1 is true. Okay, next we have to assume Pn is true. This is a simple step because you just need to rewrite the question, but don't forget to put Pn then double colon. Then don't forget to put n element in Z and n is more than equal to 1. Okay, for the third step, we have to prove that Pn plus 1 is true. So we have to substitute n plus 1, n equal to n plus 1 into n term, n variable, okay? Okay, in the both right hand side and the most left hand side, as you can see here, the most left hand side is 3 bracket n plus 1 minus 2, because before that I already stated that we have to substitute n equal to n plus 1 into n terms, so it will be like this. Okay, calculate the solution until you get the answer. It actually, you can solve it until you get standard linear equation, but to make it simple and we don't have to avoid any mistake, I will stop it until 3n squared plus 5n plus 2 over 2. Okay, for the last step is step 4. We have to prove that left hand side of Pn plus 1 by using Pn. Do remind that we already got Pn equal to n 3n minus 1 over 2 before this, which is in the step 2. Okay, then we have to calculate using this formula. Okay, we have to using this formula Pn plus n plus 1 term. That means okay, at first you have to write left hand side of Pn plus 1. Then you have to just rewrite back the question that given, which is at 1 plus 4 plus 7 plus ... 3n minus 2 plus 3n plus 1 minus 2, which is at the third step for right hand side. Okay, next, this is the main solution to prove that left hand side is equal to right hand side. So we have to use this formula, Pn term plus n plus 1 terms. That means for the Pn term, we have to just write n bracket 3n minus 1 over 2 that we got before this, then plus it with the n plus 1 term that we got at third step. Okay, then you have to solve it until you get the same answer like the right hand side. Okay, then as you can see here, for the right hand side and the left hand side give the same answer. Then it is proof that right hand side of Pn plus 1. Okay, for the conclusion, we have to write, therefore Pn plus 1 is true. Therefore, or hence, Pn also true for n more than equal to 1. Okay, next I will proceed to Nurina for question B.
For question B, next. For question B, yeah, the question is use A to evaluate 1 plus 4 plus 7 plus plus 67. So first step is let 3n minus 2 equal to 67. So we know from A, 1 plus 4 plus 7 plus plus 3n minus 2 equal to n 3n minus 1 divided by 2. So 3n minus 2 equal to 67. Equal to 67. So 3n equal to 3n minus 2 equal to 67. 3n equal to 69 and n equal to 23. So n 3n minus 1 divided by 2 equal to 23 bracket 3 multiple by 23 minus 1 divided by 2 equal to 23 multiple by 68 divide by 2 equal to 1564 divide by 2. So the answer is 782. So for the answer is 1 plus 4 plus 7 plus 67 equal to 782. So I will pass to the for my friends.
Next. Okay. For part B, we need to find out the sum of the finite set series. And take note that the last number of given finite series is 67. And then compare the 67 with 3n minus 2 in order to get the exact value of n. And then we get n equal to 23. After that, just substitute the value of n into the equation, n 3n minus 1 divided by 2, and then we get the answer is 782. So for the final answer, just rewrite the finite set series again. 1 plus 4 plus 7 plus ... plus 67 equal to 782. Next. Any question?
Okay, any question for group 3? So this induction question is form of apa? Dia adalah bentuk polinomial. Okay, so for polynomial form, it's more easy. Okay, maksudnya kalau dia keluar any polynomial form, dan dia mengharap you all boleh solve sebab dia just melibatkan fraction, you nak expand ke, factorize ke apa ke. Okay, so polynomial form is more easy sikit lah kalau compare nak bentuk yang ada factorial form ke, okay, yang ada kuasa ke. Okay, right, so ada question tak? Any question? from group 3? So kalau tak ada, okay. So thank you group 3. Move to group 4. Okay.
Thank you.
Thank you, madam.